Hey everyone and welcome back to Prefusion. I'm Anish and today we will be solving the engineering mathematics paper questions from engineering mathematics that came from the computer science engineering branch from both shifts 1 and 2. Like these are all memory based questions and whichever I can find from various sources I try to put in here. It may so happen few questions are missed. So yeah, I try to solve as many questions as possible that I can find. So the first question was like easy only because it is a probability question here. It has told that a bag contains 10 red balls. So we have 10 red balls and okay, this is from blue. Okay, and we have 15 blue balls. So I will just color this in red. Okay, next two balls are drawn randomly without replacement they are drawn. So yeah, that is fine. So we have overall bag in this, and without replacement two balls are drawn out of this. Okay, it is given that the first ball drawn is red. So we know that the first ball drawn is red. Probability that both balls drawn are red. So how can you do this? So there are two ways in which you can do this. So it is given that first ball drawn is red. What is the probability that the second ball is drawn is also red? Now what happened if the first ball is red, then it can also happen that the second ball can also be blue or it can be red. So what is the total outcome? Probability of first red. Okay, like what is the total probability of all the things? So first we can have a red ball. What is the probability of getting a red at first? When we first pick up, it is 10 by 25. Total number of balls is 25, 10 plus 15, and we have 10 red balls. So 10 by 25. Then again, what can happen? Either I can get another red ball or I can get another blue ball. So first let me take the case of red ball. So next time I'm getting a red ball. So now currently how many balls do I have? I have 24 balls only, because one ball is already taken out from that bag, and it is told here that it is without replacement. We are not replacing that ball, simply that ball is gone. So currently I have 24 balls, and also one red ball has gone out. So 9 red balls and 15 blue balls. And what is the probability of getting another red again? It is 9 by 24. So here it will be 9 by 24. Okay, now what is the other case that can happen? The other case that can happen is I got a red ball at the first when I first took out a ball. Then in the next case I got a blue ball. So now how many blue balls I have? I have still 15 blue balls, but total number of balls has reduced by 24, or like 1. So it is total number of balls is 24. So it will be 9 by 24. So this is my probability of what can happen if I take out the first ball is red, and what can happen in the second ball. Okay, second ball that I take out. Now what it has asked is that all balls should be red. So this is my desired probability. This is not my desired. So what is the probability formula? Probability is total number of sample size, like desired outcome upon total number of sample size. So desired outcome is this, that here I get 2 red balls, first red, then second red. Here first red but second blue. Okay, so my probability of getting both reds. Okay, so let me name this event as V equals to 10 by 25 times 9 by 24 divided by this thing. So it will be simply 10 into 9 by 25 into 24 plus 10 into 9 into 24. Okay, so which is equals to simply 9 divided by sorry, this will not be 9. I'm really sorry. This will be 15. Sorry, this will be 15. I'm sorry for that mistake. So this will be 15. Now what is happening here? 9 over 9 plus 15, which is 24. Okay, so simply 9 upon 24 is like it is divided by 3. So 3 by 8. So 1 by 8 is 0.125. So 3 times this is 0.375. Okay, this is our answer. Now how can I do it in some other way? So if I check this, that both of them are independent. Okay, both of them are independent events. If I take out one ball, is there any dependency on taking out that ball? Like what I want to say is, if I take out one ball, that is gone. Now is there any dependency with that outcome, with the next outcome? Is there any dependency? No, both are independent, they are not dependent. Okay, so here if I got a red ball, that is fine, I got a red ball, but it is asking what is the probability to get both red balls. So one red ball I have already got, that is already known. Okay, so another time, how will I get red ball? Now how many total number of red balls I have currently? If one red ball is gone out from this, 9 red balls. And how many total number of balls I have? 24, because one ball has already gone out. So 9 upon 24 is simply probability of second red is 9 upon 24, because they have already given it to me that first ball is red itself. They have already given it to me, so I don't need to think about that again. So the second ball also can be red in this, this is the probability. Again we are getting the same answer, that is 0.375. okay, so you don't have to think in this much, this is very simple. So this is like the that conditional probability only, because they have given you that the first ball is drawn is red. Why is not this answer? Why is this is not the answer? Because the thing is, they have given it to you that the first ball is red. You know already that the first ball is red. If the question would have been like that, what is the probability to get both red balls, and this statement wasn't given? If this statement wasn't given, then this wasn't a problem of conditional probability. How this is a conditional probability? Here you're finding the total probability. Okay, total probability. Then you're finding the desired upon the total, basically the Bayes theorem that you're using, right? So yeah, this is how you can do, or this is how also you can do, because they're independent, they're simply independent. You don't need to think about this much, because the first outcome is not dependent with the second outcome. Okay, so yeah, this is it for this question. Now this question is again simple. You have to find the median of a given series. Just take note of one thing, that whenever you have even numbers, like total number of data you have even, then what will be your median? So your median, you can't simply break it down into two parts and only one item will remain. You can't simply do that. What is median? Median is the when data is arranged in the ascending order, the middle element is known as the median. But here, in when you have even number of elements, you won't get a middle element, because there will be, let's say you have four elements, so you can't simply get a middle element, two element, and nothing is in the middle. So what you do, whenever you have even elements, then you know something is wrong, then what you do is that you just find the average of both of these elements, right, near about middle elements. So average of n by 2th element and n by 2th plus 1 divided by 2, like average is simply divided by 2. So this is what you do. This is the thing that you need to take care of. Everything else is just simple only, because if you have odd number of elements, the middle element will be just the average, basically when it is arranged in ascending order. So first we have to find the median. So first you have to arrange this in the ascending order. Okay, so 9, 10, 11, 11, 13, 13, then 14 we have 14, 15, like these are memory based, so it may so happen the data may be here and there, but the concept is same only. 15, 17, 18, 69. So here how many elements I have? Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Always check after arranging ascending order, always check how many elements they have given and whether this is matching with your order or not, how you matched your order. Else it may so happen you might miss an element. So this is also you have to take care of this, right? So here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Fine, so that is fine, I haven't missed any element. So now let's simply find the median. So as I told you the formula, right, median will be simply, as I have 10 elements, that is even number of elements, it will be average of the n by 2, fifth element, 1, 2, 3, 4, 5, and the sixth element simply. So yeah, you can do it all like that. So when you have odd elements, simply it will be the middle element only. Okay, so 1, 2, 3, 13 plus 14 divided by 2. which is equals to 13.5. okay, so median will be 13.5. This will be the answer of this question. So data may be here and there, so like the answer can also change due to that. Now the next question is very simple. You have to find the product of eigenvalues. So like this is a simple property based thing, that my product of eigenvalues will be equals to what? My determinant of the matrix A. So you have been given the determinant of matrix, you have to find the determinant and you can find the product of eigenvalues. Now like at first glance I also couldn't see it, that obviously the like the rows were dependent here, so determinant will be 0. So how are they dependent? So method 1, okay, simply if you can observe it, very good. If you can't, I have other methods also. So method 1 is simply, if you observe carefully that row 1 plus row 2 will be equals to 2, sorry, row 1 plus row 3 will be equals to 2 row 2. So row 1 plus row 2 will be equals to 2, sorry, again I'm in some other mind. Row 1 plus row 3, it will be equals to 2 row 2. okay, so they are dependent, hence determinant will be 0, hence product of eigenvalues will be 0, hence option A is the correct. Okay, now what is the method 2? Now if you don't know, like if you couldn't find out any relation, right, if you couldn't just see the relation, then you try to make zeros. You have 1 here, right? So you try to make zeros with these rows. Okay, how do you do that? You multiply 4 with this, then subtract. You multiply 7 with this, then subtract. So you try to make zeros. Okay, so 1 2 3 4 times this will become 0, this will become 0. 4 times to 8, 5 minus 8 is minus 3, then 12 minus 6 is minus 6, then 7 times this 14, 8 minus 14 is minus 6, and this is 7, so 21 minus 9 is minus 12. okay, now you can simply see, like this is so obvious, you can simply see that this is twice of this. okay, directly you can see that this will be 0, or else you just compute the determinant, you can see that this will be 0. So again the determinant of this, okay, now the determinant of A will be 0. okay, so yeah, like this you can see. Or simply method 3 is simply directly calculate the determinant, directly go to the determinant. I won't solve that. okay, so now what is the next question? Next question is a probability question, again simple Venn diagram question from basics itself. So you have been given 2 events. The probability of event A is 0.3, probability of event B is 0.5, and probability of A intersection B is 0.1. Now this one was a MSQ, this one was a MSQ. Which options is or are correct? Okay, so if these are MSQ, then like it is asking us that A and B are independent events, like telling us that A and B are independent events. Is it possible? So simple, what you do, you just multiply. Like what do you mean by independent? So if A and B are independent, that means that probability of A intersection B should be equals to probability of A times probability of B if they are independent of each other. Is it true? Simply you multiply these two, you get 0.15, and here A intersection B is given 0.1. So obviously this is not true, so this will not be true. Now all these things you have to find out. So this, either you can do it with the Venn diagram, or you can do with the formula also. So first I will solve it with the Venn diagram. So what is a Venn diagram? Venn diagram is like where all of the events are present. So here this is probability of A, this is probability of B, so A, B, okay, and this is the outside area. So this is the common section. So they have given us the common probability of A intersection B is 0.1. So this area is 0.1. okay, now they have also given us the probability of A is 0.3. Now what is probability of A? This whole area. But what is the value of this individual section? This whole thing is probability of A, but what is the value of this intersection section? The area is 0.1 here, the total area is 0.3, so this individual area will be 0.2, so this will be 0.2. Again the same thing only for probability of B is 0.5. So if this overall area is 0.5, this intersection area is 0.1, so this individual area will be 0.4. This individual area will be 0.4. okay, so yeah, this is about the this diagram. Now obviously if you find out these areas, now what is the outside area where both of them don't include? So this area is 0.2, 0.1, 0.4. So total 0.7. So overall, like any event, total sample size is 1 only. So probability of all of the events is 1. So all of this should add up to 1. So this remaining part will be 0.3. So as this is 0.7. Okay. Overall summation of all the probabilities, probability of happening event, not happening event, and all of the other events should be equals to 1. So yeah, it is 0.3. So what is this area representing outside this A and B box? This is representing that none of the events A also B didn't occur. None of the events occur here. So what is this? So it is A, like now what is the second question telling us? A not intersection B not. So B hasn't also occurred and A hasn't also occurred. So here A has occurred, so this is like this I can take, and here B has also occurred, this also I can't take. Only this is possible. This outside A is possible. This is equals to 0.3. Like I can't take B, can't take A, because this is, what is this? Complement. A complement intersection B complement. So this area is A intersection B. Okay, like I don't want A area. So what is A? I don't want A. So this is the whole area. Okay, this is the whole area where I want, because I don't want A. Again they are telling us I don't want B either. So I have to remove B also. So only this area is remaining outside A and B. So this is equals to 0.3. So my A complement B complement will equals to 0.3. Okay, which is wrong here, okay. Now what is my A union B? So I want like what is probability of A or B, either both of them, or like either A is happening or B is happening, or both of them. Okay, so what is the probability of A or B? So you can do it by formula also, I tell you, but here with the Venn diagram how you can do, I need to include this whole area, right? Because either A is happening or B is happening, or both of them are happening, but like at least one of them has to happen. In this area none of them are happening, but here at least one of them are happening. So what is the total probability here? 0.2, 0.1, 0.4, which is 0.7. So this is true. Okay, this is true. Now what is this? This is probability of A intersection not B. So B shouldn't happen, but A should happen. So where is A happening? Here. Okay, but it is telling us that A is happening fine, but B shouldn't happen. So in this region A and B both are happening. I have to remove this part. So after removing this part, obviously we get this probability 0.2, right? We get this probability. That's what we did in the first, like when you draw the Venn diagram. So after removing this, I get 0.2. Simply my answer will be 0.2. So here this is true. Yeah, 0.2 is in the option, so this is true. Now how to do this with the formulas? So simply, if you recall one thing, now this is easy. This one I did only with the formula itself. So how to do this? Probability of A complement intersection B complement. So what you can do, you can take the whole complement of this, So what you do, you take twice complement, right? These are same things only. Okay, so this will be simply probability of whole complement A union B. Okay, now what is this? This is simply 1 minus probability of A union B. Now what is probability of A union B? Probability of A union B is simply, like I'm telling you both methods. If you want to do formula, fine. If you don't want to do it like that basic also, you can do. Okay, so this is probability of A plus probability of B minus probability of A intersection B. So this is what my probability of A union B is. So you know probability of A, you know probability of B, you know A intersection B. It is like probability of A is 0.3, probability of B is 0.5, and A intersection B is 0.1. So this is 0.7. Okay, this is 0.7. Okay, so yeah, this is 0.7, and I have to put this here to get A complement intersection B complement. So 1 minus 0.7 is 0.3, which is again not present in the options. Okay, it was 0.4. Again, this I already derived it. It is 0.7, and this, how to solve this? So here, what is this telling us is that, what do we mean by probability of A intersection not B? What does this mean? Like in the Venn diagram, I have already explained this. A probability of A is overall this, which is equals to 0.3, but I only want where B is not intersecting. So B is not present. So what do we get from that? So we have to subtract this A intersection B from this overall probability, right? So this will be equals to probability of A minus, I don't want B. So I will subtract probability of A intersection B. I don't want any part of B. So like probability of A is 0.3 minus 0.1, which is equals to 0.2. So like that's what we got here. So yeah, the answer for this is C and D. Okay, so we have another question with us. So like okay, I forgot to like write that question. So this question was very good actually. We have been given a function. Okay, question, we have been given a function f of x equals to max of x cube and x. Okay, and this one also was like a MSQ, I think, I don't remember. So find all the points where basically f of x is not differentiable. Okay, so how to find that? Simply what is like, this is from the limits itself. So like there was MSQ, I've forgotten to write the the options. How do you understand this? Like, what do you mean by not differentiable? Not differentiable means the left hand derivative and the right hand derivative at that point, at near that point, is not equal. Then at that point is not differentiable for that particular function. So that is what we can do here. Or how you can see this? You can see that the slope is suddenly changing. Like how do we understand by not continuous? The value is suddenly changing. There is sudden jump or sudden like decrease in the value in the function. Then the function is not continuous. How do you understand not differentiable? If we have the graph, the slope is suddenly changing. Suddenly it is +5. Suddenly, like at that point itself, it is suddenly changing. Then it is not continuous. Like from these type of function are always either not differentiable or not continuous. First is the graphical method. We can do it using the graph. So how to do it? So simply let us draw the two graphs here of x cube and x simple x. So simple x is straight line passing through the origin. And how about x cube? So x cube, if you recall correctly, like 0.5 cube will be 0.125. So it is even lower than 0.5. So values less than 1 will be very low. Okay, in the negative sense, like it will be nearer to the origin in negative and positive sense, and values more than 1 will be more further away. Like 2 cube will be 8. So it is more higher than the initial value. So it will be something like this. Like, my plot is not exact. Okay, just try to bear with me. So this will be something like this. Now the values here where it intersects, right? At 1 it will intersect. Why? Because x cube is 1 and x is like if x equals to 1 cube is 1, and like at that value they are intersecting. Okay, and -1 cube is also -1. So this is -1 and this is +1. Okay, so these are the points where they are intersecting. Now can we understand something? What is my function? So like what does the graph of my function look like? So what does it say? It is a maximum of x cube x. What does maximum means? Maximum means the maximum positive value. So whichever part is above, that part I will take, others I will reject. Okay, so in this region, this yellow graph is above this green graph. So I will take this part. This will be included in my function f of x. So this is positive. Now what is happening next? this part is above this Euler graph, as I told, right? So I will take this. Now this part is above this, like orange graph is above this, sorry, not orange, yellow graph is above this green graph. So I will take this, I will take the cubic. Okay, now this yellow graph is down below the green graph, so I will choose the green graph. Maximum means the higher value, higher, more positive value, more positive. So this is greater than the yellow graph, so this is more positive. So my graph will look something like this. Okay, what I can observe, if I am moving from here, suddenly my slope is changing. It is going towards 0 here, like I will prove it to you, but suddenly it is changing over here. One thing, if I go from here to here, suddenly my slope is very high. Okay, it was like this, now suddenly it became this, like this. Slope is very high. Okay, slope you can understand, it is a tangent to that point. Now how can I decide my slope? I can't decide my slope. Okay, that is why it is non-differentiable at that point. Okay, so yeah, here also my slope is not slope is changing suddenly, but other regions the slope is continuous, because like these are polynomials only, they will be continuous only, and they will be differentiable only. But the problem is, as I'm using a max function, like it is making wherever they are intersecting, these two are intersecting. So where are they intersecting? When these two functions become equal, they will intersect. So my x cube will be equals to x itself. So my x cube is equals to x, then I can take x over there, so I can take x common, equals to 0. So x is equals to 0 and x is equals to plus minus 1. So in these 3 points they are intersecting, and in these 3 points they will not be differentiable, because my slope is suddenly changing. Okay, also the graph is suddenly also changing. Okay, so yeah, that is one thing you have to note. These 3 points are intersecting and they are not differentiable at these 3 points. Are they continuous? Tell me, are they continuous or not? Okay, so this will be answer, x equal to 0 plus minus 1. Now you can solve it using the method 2 as well. How to solve using the method 2? So simply what you do is like now you solve it using the conventional method. So what is the conventional method? You write the function directly. Okay, break it down into different parts. What is my function? My function is max of x cube and x. Okay, so it is simply equals to, now when my x is here, this is 1, when my x is greater than 1, it is equals to x cube itself. Okay, with aptitude also you can understand without drawing the graph that it will be equals to x cube, because very high, x cube is very high, so obviously we will take the max value. So it will be x cube when x is greater than 1. Okay, now when my x is just less than 1 but greater than 0, it is equals to this linear portion, so it is equals to x. Now as this is higher than the yellow graph, the cubic graph. Okay, now when my x is between these region, okay, this time my cubic graph is again higher, so it will be equals to x cube so this is equals to 0, oh sorry, x is greater than minus 1 and less than 0. Now again what do we observe? When again it reduces further, like lower than minus 1, again this linear part dominates, this one goes even lower it goes, hence this will be equals to x itself when my x is lower than minus 1. Okay, so when my x is lower than minus 1, this is equal to this. Okay, so this is equals to this. Now what do you do? You have to check the differentiability. For that you have to check the left hand derivative and the right hand derivative. So obviously you have to differentiate this function first at different regions. Okay, this is 3x square, this is 1, this is 3x square, this is 1, this will be x greater than 0, this will be 0 x less than 1, this will be minus 1 x 0, this will be x less than minus 1. Simply from here also you can understand the derivative of the straight line will always be constant, okay, 1, but this cubic line is changing and here we are changing the function, so that's why suddenly my slope is suddenly changing, hence this point and this point won't be differentiable, because here this straight line is telling me slope is 1, this function like x cube is telling me slope is 0, because this is almost going towards 0. From here you can cross verify. So if you write here the differentiability, it is 0, okay, sorry, it is so what did I do? Yeah, at x equals to 1, what is my this value? This is equals to 3, okay, at x equals to 1, but this is equals to 1, so these two are not equal, hence this point x equal to 1 is not differentiable, okay. Then again at x equals to 0 you check, okay, this is telling me the slope will be 1 and this is telling me the slope will be 0, you put x equals to 0 in this function, okay, this is a differentiation, we get 0, so again these two are not equal, so x equal to 0 is also not a point where my function isn't differentiable. Again you take this point x equal to minus 1, you put x equal to minus 1 here, you get 0, and you put x equal to minus 1 here, you get 3. So again like this is telling me 3, okay, and this is telling me 1, so these two are again not equal, so x equals to minus 1 is also a point where my function isn't differentiable. So yeah, these are the 3 points, x equals to 0 plus minus 1, where my function isn't differentiable, okay. So this was the answer for this question, like very simple, like good question only because this is an interesting question, because this question has got you thinking basically, because they haven't provided you direct equations, you have to think about that equation, then again derive from that, understand the differentiability, then do that. So this one was a moderate good question. So this is from the shift 2, these are the questions that I could find out. I will try to find out more questions, okay, from the shift 2. This one was like a good question only, because like okay question, because they have told you that we have 6 unbiased dice, they all of them were thrown at once. Now what is the probability that we get distinct numbers on all the dice? Okay, so you can do it in 2 methods. First method is very simple. Method 1, simply you need distinct numbers. So you are throwing 6 dice you are throwing, okay, if you throw it all at once or one by one, it doesn't matter, because they are unbiased and they are independent from each other, okay. So now let's say I throw 1 dice. Now what I can get anything, any number. I do I have any restriction? Do I have any restriction now? No, I can get any number, so I can get 6 outcomes out of those 6 outcomes, okay, I have no issues with this. Then I throw the second dice. Now do I have any restrictions now? Yes, I have, because let's say you thrown the first dice first, you got 5. So if you got 5, that means you shouldn't get 5 again in the second throw, because they have told you we have to get distinct numbers, that's why 5 shouldn't come. So if you got 4 in the first row, 4 shouldn't come, 3 in the first row, 3 shouldn't come, so obviously 1 item shouldn't come. 5 items can come, like 5 numbers can come, but 1 number can't come. So here it will be 5 items can come, but out of the 6, 1 item can't come. Again similarly for the third throw, let's say you got 1 and 2 from the first 2 throws, you shouldn't get 1 and 2 in the third throw, because we want distinct numbers. So again 2 out of those 6 samples should be gone, because you should get 4 throws, because 1 and 2 if you got, you shouldn't get 1 and 2 in the, like either 1 or 2 in the third throw, or if you got 4 and 3, you shouldn't get 4 or 3 in the third throw. So obviously you have to remove those 2 samples and then you find the probability. So what outcome can I get? I can get 4 samples, okay, because 2 samples has already come, so this will be 4 by 6. Similarly again for the fourth one, I will have only 3 options present, okay, 3 options are already gone, because 3 numbers are gone in this region. Again for the 5th row I will have 2, again for the 6th row I will have one option only present, because all the 5 numbers have gone, only one number is present, then only I can get distinct. If out of those 5 numbers any other number came up, obviously this will not be distinct. Okay, so this will be my answer. This is simply like 6 factorial upon 6 to the power 6, or this is something like 5 upon 6 to the power 5. Okay, let me just calculate this. Just wait a second. So this is 5 factorial actually. 5 factorial is 120 almost. So 20, yeah, this is 0.1543. okay, this is the answer. Now how you can do this in another way? So they have told you have to get, like, you have 6 outcomes, like 6 throw you are given, you will get 6 numbers, and you have to get distinct. Okay, and only 6 numbers are present in the dice itself. So obviously, what can be outcome of each of those? I know each of those can have outcome 1, 2, 3, 4, 5, 6. Okay, but what can happen? Like, only these 6 outcomes I can get out of the 6 throws. Like, this is the only possibility, because even if I get 5 over here, they will not be distinct anymore. This 5 and this 5 will be same again. So that's why I have to get distinct numbers. Okay, and I have only 6 numbers, and I have to get 6 distinct numbers. So obviously I have to get all the samples. Now this is fine, but they can be arranged as well. So here, what is this telling? The sequence is telling that first I am getting 1, then I am getting 2, then I am getting 3. But it may so happen first you are getting 3, then you are getting 2, then you are getting 1. So you have to arrange things here. So you can use the box method, or directly you can arrange all these things. So like, if you want to arrange 6 numbers and they are non-repeated, it will be simply 6 factorial. Or if you want to go to the basics, like how does 6 factorial come up? So what you can do, just draw the box, use the box method, and divide it into 6 parts. 1, 2, 3, 4, 5, 6. So now what you do, you just place things in each of this box. Okay, place each of this box. So how many things can I place over here? I have 6 of this, so I can choose 6 any out of this. 6C1 permutation combination, I know you have studied from Himanshu. So you have 6 options present over here, and you have to choose only one. So 6C1 you can write, or directly you can write 6. Okay, I will write 6C1. Then one option is gone here, so it is without replacement. One option is gone here, so I have 5 remaining. Any out of this, anything I have to choose. So it will be 5C1. Simply 5 it is. Then 4C1. Then 3C1. Okay, my battery is gone. Just hold on a second. Three C1, then 2C1, then simply 1C1. Now what is this? Here I have 6, like I can get 6 outcomes. Now I have to multiply by 5 here also. Why? Because like here I can place 6 things, okay, but after that I can place 5 things. This is AND, so this is AND 6 and 5, so this is multiplication. Then again 4 multiplied by 3, 2 into 1. Okay, so here I can place 6 things, here I can place 5 things, here I can place 4 things, here I can place 3 things, here I can place 2 things, here I can place 1 thing. 6 times 5 times 4 times 3 times 2 times 1. Okay, so total this is simply 6 factorial. So 6 factorial upon, now what is the total number of outcomes? How many total number of outcomes I can get? So this is the required, desired. Now total number of outcomes, how many I can get? So again, if I use the box method, okay, so these are the 6 dice throws. You can assume these are the 6 dice throws. Now what are the options present? How many numbers I can get? I can get 6, because total, I'm talking about total here. So any 1, 2, 3, 4, 6, I can get anything here. Also here also I can get anything, 1, 2, 3, 4, 6 in the second throw. Here also I can get anything. Here also I can get anything in the 6 throws. So how many total is this? Total number of samples, distinct samples, how many I get? 6 and 6 and 6. So this is 6 to the power 6, simple only. And this is a total samples. Okay, so I'm just writing it rough now. So the probability will be simply, probability of the event will be simply 6 factorial upon 6 to the power 6, which is simply again 0.01543. Okay, so yeah, and this is what my probability of E is. Now yeah, this was the answer for this question, like with two methods you can simply do this. Now this is also a very interesting question. Here you have been given a function which is related like this, that f of x plus f of 2 minus x equals to 1. You have to find the integration between 0 to 2 of f of x. Now the options are given. Okay, now at first this may seem intimidating, but whenever you see some definite integration problem directly like this, always think about some property you should think. So here what property you can think is that simply that you have to find this, right? So one property I remember, okay, if two limits are given, this is the most important property which comes up. Like if you have been given that you have to find the integration, definite integration between a to b of f of x dx, you can simply write f of a plus b, the sum of limits, minus x dx. This will be same, as this is a property of definite integration, this will be same, the limits will still remain same. Okay, this integration and this integration will be same. Can we apply something here? Yes, whenever this type of question come up, you can do this. Okay, so this will be what, with property, okay, 0 to 2 f of 2 plus 0 2 minus x dx will be same again, like this only. Okay, so now you, like this is equals to this only, like just we have to integrate this whole equation. So if I write this as I, okay, so this will also be I. So if I integrate this whole equation, okay, if I integrate this whole equation, f of x like that for dx, first equation, integration 0 to 2 f of 2 minus x dx will be equals to integration 1 dx 0 to 2, just integrating this equation. So this will be equals to I have named this as I, because this is simply just area integration, simply just area, definite integration. So this is I plus, again this is also I, because these two things are giving the final same value. So this is also I equals to x 0 to 2. So 2I equals to 2 minus 0, so I equals to 1. So my answer will be C. Okay, this is simple only, this is like not much brain you have to use, simple only. Okay, so also another question was given here, where A is a matrix of order n cross n. So A is a matrix of order n cross n. Now all the elements of A are real, it is given all the elements of A are real. Now B is another matrix obtained from A. Okay, B is another matrix obtained from A itself just by swapping the two rows. So any of the two rows are swapped of A and B is obtained. Fine. Now this was also a MSQ. Okay, this is asking that, like, if A is invertible, then B is also invertible. Okay, now what happens when two rows are swapped? When two rows are swapped, one thing we know, that determinant of B will be equals to negative of determinant of A. This property we know, that if any of the two rows are swapped or two columns are swapped, this will be negative of each other. Like now if n rows are swapped, then what will happen? So if n rows are swapped, mainly this one comes up, the n1 doesn't come up, but still it is good to recall. Then my determinant of B will be simply equals to negative 1 to the power, let me name this as m only because n is already there, power to the power m into determinant of A. Okay, so this is my determinant of B. So yeah, this is the formula simply. So here what is this first question asking? This first question asking, if A is invertible, B is also invertible. What does invertible mean? Invertible mean that inverse exists. When does inverse exist? When A is non-singular. When is A non-singular? When the determinant is non-zero. Obviously, what is determinant of A? like sorry, when inverse is, what is inverse of A? Sorry, this is wrong. Inverse of A is simply adjoint of A by determinant of A. Now if this is equal to 0, then obviously inverse won't exist. That's why this has to be not equal to 0, okay, as according to option A. Now if determinant is not equal to 0, then obviously they are same only, just the negative on each other. So if this is not equal to 0, this will also be not equal to 0. It will be just negative. So determinant not equal to 0, then determinant of B will also not equal to 0. Hence it is invertible. Because this is not equal to 0. So yeah, A option is correct. What about B? B is, I've already written it here, okay, minus A, so this will be correct only, okay, nothing to think. Now what about this C option? So they are telling us if trace of A is 0, then trace of B will also be 0. Is this true? Is this really true? Now let's just take one example. Just take one example that -1, 3, 2, and this is 1. Okay, that let me name this as A. Okay, if you can't imagine, now you can like I'll tell you how to imagine. You imagine that, yeah, I am swapping the first two rows. So at first row, my first element is the diagonal element, so that will come into the trace factor. But for the second row, my second element is the diagonal element, that will come into the trace factor for A. Now if I swap these two, what will happen? For B, whatever was the first element of the second row, that will come into the trace factor, and whatever was in the second element of the first element of the second row, that will also come into the trace factor summation. So those are not same anymore. Trace has changed, so trace will change. So trace will not be 0. But from here also we can understand that we have a matrix A. Now I'm just interchanging the two rows. It is 2, 1, -1, 3. Now this trace is 0 and this trace is 5. Obviously from here you can directly understand that they are not equal. So yeah, this option is cancelled. Okay, now what about this option? If A is symmetric, then B will also be symmetric. Now this is not necessarily true. Okay, for 2 cos 2, this will become true, but let's take for 3 cos 3. So for 3 cos 3, again you are like the row, like the elements are changing, all those things are changing, so obviously they will not be symmetrical. But if you couldn't understand, just take one example. Always take one example in the exam hall. So -1, so let me write one symmetric. For symmetric, A transpose will be equals to A itself. So this will, if this is 4, this is also 4, this is 5, this is also 5, this is 6, this is also 6. Okay, so this is A. This is A transpose equals to A. Now you just swap two rows. So it will be, first two rows I am swapping 4, 2, 6, 1, 4, 5, 5, 6, 3. Okay, so is it symmetrical? For it to be symmetrical, these two elements should be same, these two elements should be same, these two elements are they? No. This is do the like A transpose. This will be 4, 1, 5, and this will be 2, 4, 6. This will not be equal to this. Okay, so yeah, definitely they are not symmetrical. This is for the D option and this is for the C option. Okay, so definitely this is not true. Okay, so these are the questions that I got from the computer science engineering shift. So like if you some electrical and EC people are watching, don't worry, don't take any stress. Just like this can, like similar type of question can come or not come. You just, if you are watching, that's great, all the best to you. Just this is for just a bit of like practice and just keep your brain going, all those things, right? So yeah, thank you for watching. I'll see you in the next video.